Well, ladies and gentlemen, our next talk, we have Samik here with us, and he's going to be talking to us about an explainable, specification-based, aspect-oriented product comparator for e-commerce. Please put your hands together and welcome him.
Thank you. Am I audible? Okay, cool. So let's get started. Cool. So I'm here to talk about a product comparator that we built along with my colleagues from IIT Kharagpur. So Pawan is a professor who teaches natural language processing at Kharagpur, and Abhishek was his student and my intern. So it was a joint work that we did concluded about 3 months ago, right? So before we get started about the technical details of how we built the product comparator, let's first talk about why we need one to begin with. Imagine that you have built your fabulous e-commerce platform, and here is a willing buyer, right? Came looking for a digital camera. And so you have an assortment of choices for him, right? So this is the first time he's going to spend a lot of money on buying a digital camera. And so these are the kind of natural questions he would have in mind. So he knows what he's going to use the camera for, not necessarily understand all the technical details about this, right? What do we show him? So we show him a table full of specifications, so technical terms like low light ISO, right, which an average buyer is not expected to know whether it's better for, the landscape photography that he wanted it for, right? So almost every other, points that I'm showing you here, number of autofocus points, 11 versus 9, it's pretty hard for you to know that whether you need 11 to do a great landscape photography or 9 is good enough for you. So here is, so we perceive there is a gap in the information need that the buyer has. All he needs to know is between camera A and camera B, which one is suitable, more suitable for the aspect he cares about. Whereas what we show them is, a bunch of aspects which he probably doesn't know how it relates to what he had in mind, right? When he, couldn't find the relevant information in the table, he would, probably go and read reviews. Now, reviews are not always written by very authoritative sources, right? So sometimes they are written by somewhat ignorant folks. Sometimes they are written by folks with malicious intent, right? So by reading this, so I traded up my camera A to the camera B. The buyer would jump to the conclusion that although he doesn't see the mention of landscape photography anywhere, but he would probably end up concluding that camera E is not so, camera B is better than camera A. Now, he goes on and reads one more review, which paints a completely different picture, right? It says that the other camera is better than. So at the end of it, so unless he really understands that why they are saying that camera A is better than camera B or the other way around, they won't be able to make up their mind. And you probably lost the buyer here. So he will go back and do the research and may not come back to your platform. This is the gap that we wanted to address. So we wanted to address this. So e-commerce is a lonely place, right? So when you are confused, you don't have anyone to talk to. So we thought that we would build a decision support system when someone, faces this buyer's dilemma, which one to choose, right? He can specify an aspect, landscape photography for the digital cameras, right? And we would be able to tell them that whether camera A is better than camera B. He can further ask us to sort all the cameras in our inventory with respect to their suitability. So that's the kind of, that's the scope that, of this particular problem, right? And of course, so to do that, you have to rely on the data that we already hold. So 2 pieces of data. One is the specifications, the product specification that the seller uploads. And number 2, a curated labeled subset of product reviews, right? So this was the first attempt at solving this problem, and there are a lot to do in this space, but a preliminary version of this work had been accepted at CIKM as a short paper. So rest of the talk will mostly focus on the details of this paper, right? So solution sketch, how do you get started? So you first need your data, and as I told you that not every review is written by authoritative source, not every product specification is clean. You first have to, curate a portion of the data set that your algorithm will be using. So the first, so you don't use all of the product reviews. You look for sentences that compares two products in them, right? Just two cameras, camera A and camera B. You do two things. You, harvest a set of such comparative sentences, number one. Number two, for each of those sentences, you figure out whether camera A is being preferred over the other camera. So that's pretty much, so what you need to label. We'll talk about how to automate parts of this process if you want to, do it for furnitures or do it for cars, right? Then there are two pieces of machine learning models that you need to fit to this data. The first one is a choice model, right? So it relies on the comparisons that you have harvested while labeling. So it has access to a lot of ranking data, so whatever was written in the comparative sentences. And it tries to find out that why someone who had written those sentences favors those cameras, right? And it looks for an explanation in the product specification. So if you knew a little about the DSLR cameras, you would know that the low light ISO, that mysterious string that we have seen is actually better for low light photography. So if you were taking your camera out and it's twilight, that's the camera you would need with a larger value there, right? So it tries to learn that from the hand-labeled comparison outcomes. And then it also fits another model called a language model to it, right? So what it tells you is, so when this product comparator shows you that camera A is better than camera B, the buyer is going to be curious. He needs to know that why the model is doing that, right? So you might want to show him excerpts from the product reviews, only the relevant excerpts. So that's what the language model, that's the purpose that language model serves, right? Now a little bit of detail on how these models are actually built. So bear with me, there is a slight math here. So let's say that, so you're comparing two cameras, right? And you have access to their product specifications. You first abstract it out in terms of the so-called feature vectors, right? Anyone who does machine learning knows how to model their data points as feature vectors. So pretty much this is a way of encoding every information that was written in the product specification. So you get two vectors, xi and xj. That serves as your input, right? And you have got a bunch of comparisons with you. You fit something called rank SVM to it. The way it works is, let's say, I don't think that the pointer is visible. All right. So whatever that formula is, the purpose that it's supposed to serve is the following. If it sees that camera A is preferred camera, so I'm denoting them with I and J. If it sees that I is preferred over J, the W transpose Xi, it tries to set it larger than W transpose Xj. So think of what is going on in this, right? So for every, item in the product specification, you are trying to understand how important they are for the aspect, for landscape photography, right? If you want to do the same exercise for portrait photography or for sports photography, you will end up learning different versions of W, right? By fitting the same model to your the same choice model to your data, right? Once this is done, you still have to model the language, right? And what I'm showing you here is known as a graphical model in machine learning. So I will explain how to read this, right? What I'm showing you at the top is an example of a comparative sentence, right? Which compares just two cameras, right? It has got two cameras, right? Let's call one of them head, the other one tail. Those are the, so you guys have heard about named entity recognition in earlier talks. So when you throw a named entity recognizer tuned for this camera vertical, it will come back and tell you that there are three entities here. You mark the first one as head, the second one as tail, and the third one is a repetition of okay, it doesn't contain free. So that's what the named entity recognizer does for you, right? Apart from those entities, you have this bunch of words, right? And so for example, great is something which was pretty indicative of this, which way the comparison is going to go. So the head entity, the word, and the tail entity, they are pretty much the things that you want to model when you want to model the language in the review, right? So that large box that you see on the right-hand side tagged with S is one such sentence. It's a fancy way of writing, do the same thing for all the sentences that you have in your data set, right? Inside it, there is a smaller box, which says that do it for all the words that appears in the sentence, right? Another for each statement. Now, and I will explain what the other circles here does, right? So I just explained that the inner box, the features inside it are pretty much the words you see in the reviews, right? And a bag of them. So if you are familiar with how people model text in the statistical machine learning literature, so you would be familiar with perhaps this way of modeling things. So topic model is an example of an advanced version of this, right? Now, what does the other nodes serve? The variable there, the CS, all it does is, see, when you start processing a sentence, you don't quite know, right, that whether the head own over the tail or not, right? So it's up to the algorithm to figure that out. The way you encode it in your machine learning algorithm is by marking that outcome of the comparison is a random variable, right? It can be 0 with a probability, 1 with 1 minus that probability, right? That's up to the algorithm to figure out. So the variable CS here is records that, right? Now, there are, okay, so ignore what is there for marked as alpha. There are two thetas up here, right? So they are known as language model. I will show you what they look like in the very next slide. All they want to model is, the theta 0 tries to model if this is a sentence where head own over tail, this is the kind of words that you will see in the sentence, right? And theta 1 models the symmetric counterpart of it, right? The way this language model assumes the reviewer had written the sentence is as follows. While he is starting to write the sentence, he tosses a coin, decides that whether head wins over tail or it's the other way around. If head wins over tail, right, for every word, he keeps drawing from that thing called theta 0, right? When you draw from it, you get a word, you put it in the first position, you draw from it again, independent of what you have done in past. You get another word, you keep on stacking them until the sentence is complete. So this is typically how a piece of text is modeled in the statistical part of machine learning, right? Now it's up to, so when so there are parameters that this algorithm needs to learn from the data, and I will show you what it finally ended up learning, right? So you remember, so what I'm visualizing here are those theta zeros and theta ones that you have seen. So we're talking about one aspect, not the landscape photograph. You didn't have labels for that. So we had label for an aspect called form factor, right? It's pretty much how your camera feels in your hand, dictated by the size and the shape and the weight of your camera, right? For that aspect, so once you fit your algorithm to all the comparisons, to all the comparative sentences, the language model it learns is if head is preferred over tail, people are going to use this word lighter than, smaller, far more than what you see on the other side, right? Now, what I have shown you are two distinct models, right? A choice model that works on the product specification and a language model that works on the product reviews. You need to put them together, right? So the way it is done is, you first fit your choice model. The output of it is this weight vector that I have shown you, that how important different specifications are. So that comes out when this learning is done. You initiate your language model with that. You don't have to understand that, all that equation here. All you need to know is the W that was the output of the first block is used in the language model as well, and at the end of it, it's going to give you another W, which you pass on to the other block, and you iterate until convergence, right? So that's pretty much how this particular algorithm works. And, so it's, since it's a short, I'll show you how it performs in practice, right? So what we did is we took about a set of 200 cameras, right? A set of 1,000 sentences, comparative sentences that compares them, right? And we learned that for different aspects, so you see the aspects on the first column, functionality, form factor, etc., right? Which of those, okay, so you pick any pair, right? So 180, choose two combinations, right? You pick any of them. You ask this product comparator, this is A better than B for this particular aspect, right? And if this algorithm gets it right, so you score a +1 there. So what I'm reporting you is the accuracy of that comparison, right? Larger the number, better it is. The extreme right, the last column is the algorithm that we came up with. And the middle two columns are the baselines. So one of them was state of the art in 2014, right? So you see that apart from the form factor, apart from the topic form factor, this algorithm outperforms the other in most of the cases, right? There is a lot to be done here, so we wanted to generalize it to other aspects that people care about. Landscape photography is something that I promised I would show you, but haven't. So you want to do the same thing for other product verticals as well, right? And we just got started, and hopefully from this exercise, a useful product comparator comes out, right? So, okay.
Any questions?
Hey, couple of questions. One is it sensitive to a particular, Samik?
Huh.
Is it sensitive to a particular product? And the other was, what is are the reviews of comparative reviews of the two products. Are those like in the data that you showed us, was those reviews from Flipkart product pages or gadget reviews from The Verge or something?
Well, it's from Amazon. So since you are, since I'm showing you a comparison with a baseline that was state of art in 2014, you have to operate on the same data, right, to show that your algorithm really outperforms theirs. So that was the reason why you choose the data set, but it's from a hand-curated portion of Amazon product reviews. Okay. And was there another part of the question that I missed? Okay.
What I asked was, you showed us cameras. Like,
Right.
do the results remain largely the same if you were to compare smartphones or?
We haven't done that. So we did it only for cameras so far. So rolling it out for other verticals is something we haven't seen yet.
Hi. So actually, you have picked a use case which actually I was very interested in,
Okay.
and I gone through the same process, and I was confused with the technical things of the camera. So my question is, how is it valid to totally rely on the user comments as far as camera comparisons are concerned? So because many of the comments might be of novice users, only few comments might be of expert users, and generally they compare 4-5 cameras, and then they list out the best one or best two.
Right.
So is your algorithm taking into the account of the user profile or his past activities, his purchases, all these things?
Sure. Good question. It actually doesn't. So there are two pieces of data that this algorithm depends on, right? Not just the reviews, but also the product specifications, right? And so think of it as an aggregator. So you go to the camera's brand, their website, to gather the product specification. Chances of getting a wrong product specification is less, right? So that's how you build up that data set. That data set is going to be of higher quality and lesser noisy than the reviews. Now, we do not expect the product ratings as input, right? So a lot of malicious and adversarial activity actually happens in the product ratings, right? Also, we do not use all of the product review, right? We only look at sentences that compares exactly two products, right? And there is no reason why you can't get it from kenrockwell.com or tpreview.com, which are much more authoritative sources, right? But so that's how you can fight against the noise in the data, but it's not built into the algorithm.
Hey, Samik. Yeah, so two parts to the question. As a customer, what I'll be interested in is not just a binary superiority index, but maybe some extent of degree of superiority. And also, it's even in the case of camera, it's not about a binary decision that this camera is better than, like you said. It's about facets within the camera and applying the same kind of a heuristic for each facet and throwing it up so that I tend to choose what kind of a mix and the degree is what I can relate to more. So how far are we from that journey?
Right. So the prototype that we could build, works for digital cameras, and it works for a handful of the aspects, right? So these four and a couple others. So the way it looks is as follows, right? So you have this, imagine the usual Flipkart comparator, right? Two columns, one for camera A, another for camera B. You also have a drop down, right? So from which you select the aspect that you are interested in, right? It's going to compare those cameras according to the specification. It's going to show you that low light ISO is indeed important for landscape photography, right? Along with that, it's going to show you choices from the comparative sentences on the right? So think of it as when you begin your research, right? So even before you started reading your blogs, so that's when you come to this decision support system. So There are some steps which requires manual labor, right? When you want to include your next favorite aspect to it, there is some manual effort that is needed. When you want to roll it out to another vertical, again, there is some more manual effort. So that's something we thought we would work towards reducing, but this is what we have got at present.
Any more questions? Well, I think that's it, Samik. Thank you so much.